So, the distribution of electrons in the various energy shells of an atom is governed by a scheme which is called Bohr-Bury scheme. This is the scheme, Bohr-Bury scheme. So, the rules of Bohr-Bury scheme of electronic configuration are as follows, that the amount of energy in the various levels increases as we go further away from the nucleus. The shells are marked as K, L, M, N, like that. Okay. So, the energy level of K is less than L, is less than M, is less than N, always. Okay. The maximum possible number of electrons that can be present in any shell of an atom is governed by the formula 2n square, where n's not capital N, it's small n, is the number of shells. So, when n is equal to 1, that means the first shell, then number of electrons will be 1 square into 2. So, 1 into 2 means 2. That means in the first shell there can be only 2 electrons. When n is equal to 2, it is 2 into 2 square. That is 2 into 4, that is 8. When n is equal to 3, it is 2 into 3 square, that is 2 into 9, that is 18. That means in the first shell, that means when K shell will have 2 electrons, L shell will have 8 electrons, M shell will have 18 electrons, the N shell will have 32 electrons. This is the capacity of the shells to hold the electrons according to the rule. But remember that the outermost shell is called the valence shell, and the valence shell cannot accommodate more than 8 electrons. Though the N shell or the M shell has capacity more than 8, yet it cannot hold more than 8 electrons, because the presence of 8 electrons in the outermost shell makes the atom stable. So, suppose we move on to the electronic configuration of an element having atomic number 8. Atomic number 8. Write it down, girls. 8 means number of electrons will also be 8. So, in the first shell, how many electrons? 2. In the second shell, how many electrons? 6. Now, if I take another element where the atomic number is 11, if atomic number is 11, the number of electrons is also 11. So, number of electrons. So, in the first shell, it will be 2. In the second shell will be 8. In the third shell, there will be 1 electron. So, the valence shell is called the outermost shell, which has 1 electron. Now, suppose if I move on to an element which has atomic number 15. Atomic number 15 means number of electrons is 15. So in the first shell it will be 2, in the second shell it will be 8, and in the third shell it will be 5. Clear? Okay. Now I'll move on to an element. Where the atomic number is suppose 20. So number of electrons should be also 20. So if number of electrons is 20, then how do I distribute the